Hello everybody. Today we are going to create our first agent. So this will be a series where we will create multiple agents from scratch in LangGraph. Today we are going to create an investment memo generator in LangGraph. Okay, I'll I will show you everything from scratch. I'll code everything from scratch. You can follow this code, or if you're new to it, then of course follow this code, and if you know something about LangGraph and tools and everything, then you can change in this code. So what we are going to do, a basic understanding is that we are going to create three tools. The first one is Wikipedia tool, Tavly tool, and then the third one is Archive tool that are already present in LangGraph, and we will use them to code our first agent. Okay, so let's start. The very first thing we will do is to create our virtual environment. So I'm using UV package manager because it is very fast and lightweight. So first we will use open our command prompt terminal, that is, and then we will run pip install UV. If you already have UV installed in your laptop, then you don't have to install it again, since in my laptop it is the requirement is already satisfied. The next thing we are going to do is to create our first virtual environment. So we will do UV init and then UV venv. This will create our virtual environment. You can follow this command to activate your virtual environment. Now as we have our virtual environment set, now we will start coding. Before that, there are a few things I want to tell you. We will create two files, sorry. The first one is requirement.txt, where we will keep all our requirements ready that we are going to require for this project. The second one is .env file. Now in the .env file, we are basically keeping all our environment variables. The Since I'm using an Azure Chat OpenAI LLM, so for that I will use different OpenAI keys. Okay, you can use multiple other keys from OpenAI to Gemini or Grok. These are free to use. I'll make another video where I will give you how to use the how to generate these keys. So I will not show you my .env folder, but I will tell you what are the things that are required in .env. The very first thing is to for LLM you require an API. You can have LLM in OpenAI or Gemini or Grok. Then since I'm going to use Hugging Face all mini LM model for my embedding conversion, although we are not using this in this project right now, but in further when we will implement RAG, then there we require Hugging Face key. Okay, then the third one is that is required, that is Tavly key. So you can go to the Tavly website. Now we are going to our project folder. So this is a project folder. So I'm creating a requirement.txt file. Okay, so what are the things we require? The first one is LangGraph. Then we require LangChain. Then we require LangChain community. LangChain core. We require LangChain OpenAI. Then we require .env, that is very important to load our environment variables. We require beautiful soup. Then Wikipedia, of course. Tavly Python. We require request. We require archive, ChromaDB. though we are not using ChromaDB now, but in our future period we are going to use similarly fast. So we should not we will not use that. Streamlit, may we will also be creating an app. Then we require okay, so IPy kernel. Okay, that is important. Okay, so these are all the requirements that we require. So we will run uv pip install -r requirements. Okay, it will install all our requirements. Now why I was using uv, because it is very fast, so you will see the downloads will be very fast. If you're using normal pip, then it would have taken a lot of time. So we will start this. Okay, so this we have installed it. Now we are going to create our first the file that will contain the our code. Investment .ipynb. Okay, we'll see it's running or not. Okay, so our kernel is ready to run. So now we'll write the code. Okay, I'll also be explaining you what this code is doing. So first of all, we need to import some things. That is, we'll import os, we'll import .env. Okay, import .env .env. Then we are going to import the Azure Chat OpenAI, LangChain OpenAI, import Azure Chat OpenAI. Okay, then we are going to import tools that we are going to use. So this is very important that we import tools from LangChain core dot tools, import tool. One very important thing I want to tell you is that since these frameworks new versions come, very frequently, so you have to be very up to date to check which version currently we are in and what sort of command we have to write to import something. So since I was learning on previously on some other versions, and now for that to do new things I have to change the whole code, so you just remember that. Okay, then we will import Tavli search tool and rsiv. Okay, so for Tavli search tool we are going to write from okay, langchain community dot tools dot Tavli search import Tavli search results. Then we are going to import rsiv runner and Wikipedia query run. Okay, so wait a second, we'll import that from langchain community dot tools import rsiv query run, comma Wikipedia query run. Okay, now we'll import Wikipedia wrapper, we require a archive wrapper and Wikipedia API wrapper. So for that we'll import from langchain community dot utilities, uh, utilities import Wikipedia API wrapper, comma archive API wrapper. Okay. Now the next thing we are going to import is LangGraph. Of course, we require state graph and end for creating the graphs in LangGraph. Graph import state graph. So this code, we have run this code. Now we will use okay, so now I'm going to you know import my .env folder. You can also populate your .env folder according to the thing. Now the next code that I'm going to write is customizable. You can create your own version of this code, this part of code. So I'm going to create .env file. Okay, one thing, I'm not going to show you my .env file, so the video will cut here and then we'll start again. Okay, so now you can see that we have imported the next code that I wrote was import OS. I get again imported OS, and from .env load.env I have imported the this, and then this is again I have done this import again, so you can skip this. Now I created the LLM, that is Azure Chat OpenAI. This is my, and I have in my .env folder all these endpoints and API keys and deployment name is there. So this is how I initiated my LLM. Now LLM invoke, this I have written just to check whether my LLM is working or not. So this part of code is completely customizable. You can customize according to your needs. You can use Chat OpenAI, you can use OpenAI chatbot API or Grok or Gemini or any other API that you want. I will recommend you to use Gemini because it is not paid. Okay. Now the next thing, we'll start again. Okay. Now the first going to create the archive API wrapper. So API wrapper for archive is equal to archive API wrapper. Now in this API wrapper we are going to pass few things, that is top key results. This will bring us the top key results. Okay, so we are taking 2, this number as 2. Then we are going to initialize document, that is how much document you want. So document content that is equal to max, we are taking, let's take 500 for now. Okay, the next we are going to 500, and then we are creating a function. Okay, function, for why we are creating this function, so that we can use it in the tool. Okay, so we are going to archive tool function. Okay, now there will be a query which will be of string, and we are going to send a string as response only. So this is for that. Okay, now we are going to print. Okay, print what we are printing right now in here. So when this tool is being used, we want that the our LLM should show that he or the LLM is using this tool. So that's why we are using a remark here, using tool archive. So this will show that the LLM is using the archive tool. Okay, now the next thing we are using to, we are creating a archive runner. Okay, archive runner is equal to archive query run, archive archive query run, and there we'll find the will paste the API wrapper. API wrapper is equal to API. We have created API wrapper. Okay, now this is the first tool we have defined, and since we have created this, now we'll define the tool. Okay, so we have created the API wrapper, then we have defined the function that we'll use in API in our tool, and now we are going to create the tool. So we are going to tool archive is equal to tool. Okay, and then by creating the name of the tool, that is equal to rsiv. I'm going to give a description also, that is required, because when the LLM is using it, then it should know why you're using it. Search as SEA, such as academic papers on rsiv related to a company or topic. Okay, now this is our description. Then we are going to give the function rsiv tool function. Now this is the first tool that we have created. We'll run this code. Okay, this is simple. This is we have run. Now we'll create the tably tool. Now for tably tool, we require just the function, so we'll create definition and tably tool function. Here also we'll get a query in the form of string. Will generate a string response, and the first thing it will do is to print by using tool tably. Okay, so this is the first thing we have written. The next thing we are going to write is uh, runner. We're going to create a tably runner. Tably search results, and we are going to API key, that is API key. Using an API key that is equal to os.get os.get and name of our API key is tably API key. So this is stored in our .env folder, and we are going to return this. Return tably runner dot invoke query. We are going to create okay, so we are going to tool up. Now we are going to create a tool. Tably is equal to tool name of this. I'm going to give it tably search tool. Okay, then description performs okay, so we are going to give it performs a live web search for the latest financial and market information. So now we've created the description also, and then we'll pass the function as this function is equal to tably tool function. Okay, we'll run this code as well. Now we are going to create the API wrapper Wikipedia for Wikipedia. So API Wikipedia, yeah, okay, wrapper Wikipedia, okay, and we're going to Wikipedia API wrapper, and here we are going to pass few things. That is, the first one is top key results, and the same things document content characters. So top key results we are going to take 2, and we are going to take the document character max is 500. Okay, you can customize this according to your own needs. Definition, we're going to write the definition, that is a function. So Wikipedia tool function query string. We're going to take a string and generate a string. Okay, now the first thing is, when we are using this tool, we should know that the LM is using this tool, using Wikipedia tool. Okay, now we're going to write Wikipedia runner. Wikipedia runner is equal to Wikipedia API wrapper. Okay, no, query run. Okay, wait, Wikipedia query run. Wikipedia query run, and we're going to pass the API wrapper. API wrapper is equal to API Wikipedia. Yeah, so this is the Wikipedia API wrapper we have used, and we're going to return Wikipedia runner dot run, and we're going to pass query. This is by far we have done the initialization of tools. Okay, wait, the third tool. Okay, so till now we've done, and now we're going to create the tool, Wikipedia tool. Wikipedia is equal to tool. Okay, given the name as Wikipedia, description as fetches background information about water company or topic from Wikipedia. Okay, and then we're going to pass function equals to Wikipedia function. Okay, this we have created all our tools. So we have created our RCIF tool, Tavly tool, and Wikipedia tool. The next thing we are going to write is, we are going to create nodes. Now these nodes are very important. So before I create the node, I want to tell you what these nodes will do. So the first thing these nodes will do is, when you're going to create three nodes, that is the retriever node, analyzer node, and writer node. Retriever node will retrieve documents from Wikipedia, archive, and Tavly. Analyzer node will analyze our documents according to the way we want to create the document, and the writer node will write the document for us. So let's initialize the first one, that is the retriever node. Okay, definition, retriever node. State. Now why we're creating state is because state is used in LangGraph. State is used to pass information among different functions or nodes. Okay, and this is very important, so that in when we are going to use again in further, it will be easily used. Okay, company. Wait a minute, we've done something wrong. Is there equal to? Okay, now company. Okay, so we have to print that we are gathering information for company. We are going to use few remarks here and there, so that we know what we are doing. Gathering information for, wait, we've done something wrong. For the company. Okay, now we'll run few things, that is, we'll run the Wikipedia tool, the web search tool, and the RCIF tool. So Wikipedia data. Wikipedia data is equal to Wikipedia run. Run is company, that's the first thing. Then web data is equal to Davily run. The Wikipedia data, web data, and research data. Now we are going to combine this data. Data is equal to, so we are providing this Wikipedia data, then we're taking web search, that is web search. Okay, web search is web data, and then we require the archive research also. So for that, archive search is research data. Okay, now we have created the combined data, and we'll, return this data. Now we are returning this data in certain format. Okay, so just take a look at this format. So we are going to return in a dictionary format. Retrieved data is, okay, wait a minute, retrieved data as combined data. Okay, so we're returning this from the retriever node. Why we are returning this as retrieved data, you will know after some time. Retrieve data. Okay, so this is the first node that we have created. Retrieve data, we have created the retrieve data. Now we will create the analyzer node. Now analyzer node will will provide it some information. The definition will consist of what the LLM has to. You can see we have created our own analyzer node. This is our analyzer node. You can read what we are going to, and we are using state and retrieve data. The state, as we know, that contains a retrieve data called as dictionary. Okay, and when I call this retrieve data, I'm also taking the combined data from the retrieve node. Okay, now we are going to write the writer node. For writer, so you can see this is our writer node. We have given the prompt as, based on this analysis, generate a professional investment memo for the state and companies. As we know that a state consists of the company name, so that is a dictionary. So we are calling the company name. And what are the sections we include? We include the company overview, key financial insights, market trends, risk and challenge, and recommendations. Use a confident and analytical tone. Why we are using this? So that we get the information. Now the information is provided as analysis. This our analyzer node will analyze it, and our writer node will write. Now these are all the things you prompt, as in prompt I have written it, but I've also taken some help from the chat GPT. So to understand what are the things that we require in an investment memo. Okay, so we've created our all the tools, that is retriever tool, then analyzer node, and then writer node. Now what we are going to create is very important. We are going to create a class, that is the investment memo state class. Investment memo state. Okay, now and we are going to pass this type date. Now why we are doing this? We are writing this type date because we require this class to return a dictionary. Company as string. As I told you, the state consists of dictionary as string. Then we have retrieved retrieved we use retrieve data as also string. Then we are using analysis also as string. Then we are using memo as string. Now we know that here the memo is generated and that is also string. So we have created this class and we'll use. Now we are going to create the graph. Okay, type date something is wrong. I must have done some spelling mistake. Type date is not defined. Type date is not defined. Must have defined earlier in my. Okay, so let's define it. Wait a minute. From typing import type date type now if you just, yeah, the import has been done. Although I have imported earlier, I think I haven't imported. Okay, so we have imported the type date and we've created this. Now we'll create our graph. Now this is very important. As we are going to create our graph, first of all we'll create a node. Okay, so graph equals to state graph, and we are going to pass investment memo generator state, and then we are going to create node graph dot add node. First one is retriever comma, we're going to pass retriever node. Then we're going to create add a graph dot add node as analyzer as analyzer node, and then we are going to create the writer node graph dot add node, and we are going to create writer node as just writer only, writer node. So we've created all our nodes. Now we'll create the edges. Now to create the edges, as we've created the nodes, now we'll add the edges. How the edges will be added? So graph dot add edges, that is retriever to analyzer and analyzer to writer and writer to end. So first one is retriever to analyzer. Then we have graph dot add edge, we have analyzer to writer, and then writer to end. Graph dot add edge, writer to end. Now we've created all the edges. Now we'll compile this graph in investment memo graph as investment memo graph equals to graph dot compile. We're going to compile this graph. Okay, wait a minute, we have done some edge. Graph must have a start point. Okay, we have. Okay, so what? So where we are going wrong? We actually forgot to create the start node. So we have created this line. We have written this line graph dot add edge start, and we are starting from retriever. Okay. Also, we have added from in the imports. We have imported from LangGraph dot graph import state graph and start. So you do this and run this cell, and then again come to this cell and run this cell. Okay, your graph will be compiled. Okay, now we will run the code and we'll see the results equal to investment memo graph dot invoke, and we'll pass company company. Okay, wait a minute, done something wrong. Company as Apple. Let's pass this and we'll print result results memo, because the result is stored in memo. We have got the answer. It took us 3 minutes to run this cell for Apple, and the content is investment memo, Apple Incorporation company overview. Then is a leading global technology company known for its innovative products and other things. And here you can read the whole memo. This is all the content in here. You can format the content and run. You can create a Streamlit app and format it and create an app for it. So this is your first agent that we've created, and congratulations if you have come this far. Then thank you.